Welcome to the deep dive. Okay, so what if I told you that the entire scientific revolution, the age of sail, even the blueprints for modern warfare, all hinge on a concept you probably ran into in high school math?
You're talking about trigonometry.
Exactly. We're diving deep into the trigonometric table.
Yeah.
This seemingly simple tool didn't just organize geometry.
No, it gave them the hard numbers, the quantitative proof they needed to basically rewrite the universe.
And that's our mission today, isn't it? To trace that technical evolution and understand the huge problems it solved.
For you, let's say, as a 16th century observer, we have to start with the biggest problem of all, the planets.
Right, that mysterious backward dance they do.
Retrograde motion. How in the world do you explain that if you think the Earth is the static center of everything?
That was the medieval dilemma, Ptolemy's big problem.
A huge problem, and his solution was, well, it was to staple together these dizzying geometric fixes.
Epicycles on top of deference. I've heard it called a mathematical Frankenstein.
That's a good way to put it. I mean, it was beautiful in theory, but in practice, almost impossible. You needed 7 separate parameters to predict where one planet would be.
And the tools they had were, what, these old chord tables?
Exactly. They divided a diameter into just 120 parts. It was cumbersome, it wasn't precise, and it was, just holding back human understanding.
Okay, so Copernicus comes along. He says, look, the sun is the center. That sounds simpler. So why would he need a massive mathematical upgrade? Wouldn't a simpler theory mean simpler math?
That is the core of it, really. A simpler concept, yes, but to prove it? If the Earth is moving, the whole geometry of the cosmos changes.
So you need much better calculations.
You need extreme, non-negotiable precision. Copernicus just couldn't use those old crude tables. He needed a technical leap.
And what was that leap? What did he propose in De Revolutionibus?
He basically set the new standard. He argued, okay, 360 degrees in a circle, yes, but the diameter itself, that needs to be divided into a staggering 200,000 parts for real accuracy.
200,000.
But here's the thing. He defined the need, but the immense, tedious labor to actually create this that fell to his disciple, Joachim Rheticus.
Rheticus. So he's the one who turns this idea into a technical masterpiece.
He's the real technical genius here. His 1551 work, the Canon Doctrinae Triangularum, that was the turning point.
What made it so different?
It was the first timetables featured all 6 trigonometric functions. Sine, cosine, tangent, the whole lot, all tied directly to the angle itself.
Which was new. Before it was mainly about chord lengths, right?
Exactly. This new system of ratios, calculated with this unprecedented 10-digit precision in tiny 10-second increments, that's what made modern quantitative astronomy possible.
And with this new tool, the universe just unlocked.
Completely. Copernicus didn't just have a theory anymore. He had proof of scale.
The ability to actually measure the solar system.
Yes, take Venus. By measuring the planet's maximum visible angle from the sun, he could use a simple right triangle, now solvable with Rheticus's tables, to calculate that Venus orbits at 0.7 times the Earth-Sun distance.
A calculation that was totally impossible under the old system.
Impossible. But the impact, it didn't stay up in the heavens.
No, it hit the real world hard. It shaped the age of sail.
Oh, it was absolutely essential for navigation. Calculating your latitude using the stars demanded these tables, but even more critical, it enabled great circle sailing.
Which means sailors could finally figure out the absolute shortest path across a spherical Earth.
Cutting down voyage times, changing trade, changing everything.
And on land, it became a matter of national defense.
Precisely. Since the 15th century, with the rise of artillery, these tables were critical for surveying, but they were paramount for military engineering.
Designing those big star-shaped fortifications, the bastions.
Exactly. Engineers needed precise angles to make sure their cannons had flanking fire coverage to eliminate any dead zones. This math was literally the blueprint for early modern conflict.
So when you put it all together, what does this mean for you? The trigonometric table, it wasn't just a reference book. It was the engine that allowed science to compare theory with observation.
It let them compare an idea with hard numbers. It drove the whole scientific revolution.
Which brings up a final thought.
Look at the technology you rely on right now. Your GPS calculates your position using spheres and angles.
Right.
The electricity in your house, that's AC current, it's delivered in sine waves.
Which is pure trigonometry.
All of it. Digital signal processing, Fourier transforms, it's all built on this. So every time you open a map on your phone, you are relying on a precise set of ratios that a student of Copernicus calculated over 470 years ago.
The hidden trigonometry that's still building our world.